They call it the sustaining lander program. So that lander is designed to be reusable. It can land on the surface of the moon in a single stage configuration and then take off. So if you look at the Apollo program, the lunar lander in Apollo was really two stages. It would land on the surface, and then it would leave the descent stage on the surface of the moon, and only the ascent stage would go back up into lunar orbit where it would rendezvous with the command module. Here, what we're doing is we have a single stage lunar lander that carries down enough propellant so that it can bring the whole thing back up so that it can be reused over and over. And the point of doing that, of course, is to reduce cost so that you can make lunar missions more affordable over time, that's one of NASA's big objectives, because this time, the whole point of Artemis is go back to the moon, but this time to stay. Mm-hmm. So, back in the Apollo program, we went to the moon 6 times and then ended the program, and it really was too expensive to continue.
And so there's a few questions there, but one is, how do you stay on the moon? What ideas do you have about like a sustaining life where a few folks can stay there for prolonged periods of time?
Well, one of the things we're working on is using lunar resources like lunar regolith mm-hmm. to manufacture commodities and even solar cells on the surface of the moon. We've already built a solar cell that is completely made from lunar regolith simulant, and this solar cell is only about 7% power efficient, so it's very inefficient compared to the more advanced solar cells that we make here on Earth. But if you can figure out how to make a practical solar cell factory that you can land on the surface of the moon, mm-hmm. and then the raw material for those solar cells is simply lunar regolith, then you can just continue to churn out solar cells on the surface of the moon, have lots of power on the surface of the moon. That will make it easier for people to live on the moon. Similarly, we're working on extracting oxygen from lunar regolith. So lunar regolith by weight has a lot of oxygen in it. It's bound very tightly, as oxides with other elements. And so you have to separate the oxygen, which is very energy intensive. So that also could work together with the solar cells. But if you can, and then ultimately, we may be able to find practical quantities of ice in the permanently shadowed craters on the poles of the moon. And we know there is ice water in those, or water ice in those craters. And we know that we can break that down with electrolysis into hydrogen and oxygen. And then you'd not only have oxygen, but you'd also have a very good high efficiency propellant fuel in hydrogen. So there's a lot we can do to make the moon more sustainable over time. But the very first step, the kind of gate that all of that has to go through, is we need to be able to land cargo and humans on the surface of the moon at an acceptable cost.
To fast forward a little bit, is there any chance Jeff Bezos steps foot on the moon and on Mars? One or the other or both?
It's very unlikely.